Good evening, everyone. Welcome to the Pykonik Tech Talks meetup number 58. Today we have 3rd November 2022. My name is Arthur. I'm going to be the host today. And welcome to everyone on the stream as well. So the agenda for today is very simple. We're going to have one talk. It's going to be along 3, maybe 4. If you don't know what a lightning talk is, it's basically an open mic session. You have 5 minutes. You can talk about anything. You can have slides, you can have demos, or you can just talk. And yeah, so we have lightning talks afterwards. And then after the lightning talks, we're going to get together and take off somewhere for an after party. Let's talk about sponsors of this event. So we have SpotOn. Because of the SpotOn, we have the place and the pizza and the drinks. Drinks are over there, so we can just use those refrigerators. I can see everyone already found the pizza. Then we have Krakow Linux User Group, who are the sponsors of our streaming today, streaming and recording. So this will be available later on YouTube. And also, probably after the lightning talks, or shortly before the lightning talks, we're going to give away 2 JetBrains licenses, including Python professional licenses. So JetBrains is also a sponsor of this event. And without further ado, let's give a round of applause to Dominik, and let's hear about fuzz testing.
So I'm Dominik, and I'm going to speak about secure Python code with fuzz testing, or basically about fuzzing in Python. Few words about me. I have a blog on the internet. It's not super active, but you can check it out. I also play Capture the Flag competitions. Those are security-related competitions in Jaska the Fish team. I'm also maintaining an open source project called Debug, which is a plugin for GDB for low-level debugging. And professionally, I'm a security engineer at 12bits, and I'm doing security audits of different software. Not necessarily Python related, but sometimes as well. So a few questions first. Who fuzzes their code? Raise your hand. Pretty much no one, okay. So who uses hypothesis? That's a Python library. Okay, also no one. And anyone here writes C extensions for Python? A few of you, great. Okay, so let's maybe start with some fuzzing 101. So fuzzing basically is an automated technique for testing programs. It's usually used for like security testing, so we want to find some security vulnerabilities. And the way it works, we provide some invalid or unexpected or random data to your program as input, and then we are monitoring this program to see to look for some edge cases like crashes, exceptions, some failed assertions, or other situations. And the way it works, or a simple diagram of like a dump or naive fuzzing can look like this. So we start with some input corpus or generator. So we have something that generates our inputs to the program. Then we mutate those inputs. By the way, those inputs can be, I don't know, like JPEG images if you are testing some kind of JPEG parser, right? Or maybe HTTP requests if you're testing your HTTP API. And then after mutating this input, you test your program or function against this input. And you monitor your program. And if you find an edge case, you save it for like further investigation. And this is kind of hard part, how to find those edge cases, obviously. And you repeat this process. So this is dump fuzzing, and this is actually what hypothesis framework allows you to do, but you can do better, and we will show later why exactly. But the way you can do better is that you can monitor your program in such a way that you will check where your program goes, into which like branches in your code. Like you can see whether it entered a given if condition or not. And if a given input entered an if condition, then you would basically save this input for further mutation of this input. And this behavior is called, or this flow is called coverage guided fuzzing. So it looks pretty similar, but on the monitoring side, we check whether we found a new path in our program with the input that we provided. If we didn't, we basically restart, right, with another input that will be mutated. If we found another input, then we check whether this input like gave us some kind of edge case situation, like a crash or exception or something. If it didn't, if it didn't, but this is still a new path, then we save this input that provided us a new path, that generated us a new path into the program for later mutation, right? And if we actually found an edge case, we will save it for further investigation. And we'll, of course, repeat the process. And as I said, Hypothesis, the framework for property testing in Python, is like dump fuzzing. And here I have a very short example from Alex, who is not here today, but it's a slide from him. So here we have, well, we basically import Hypothesis framework, and then we have our testing function. This is a test written in PyTest framework, but that doesn't matter that much. So this test will check for some email string, or I don't know. This is probably going to be some kind of rendered HTML into email or something. And then with Hypothesis, we have those decorators, like given that the body, the argument that will be passed to this test, is a text actually. So this will be generated as a string. And we also can provide an example like this. As you can see, this is some kind of HTML here. And we can also like provide some settings for this, like, hey, we'll have maximum of 20 examples, and we have no deadline for executing those. Because you would have lots of examples, maybe there is some kind of timeout we want to have in the program. And if we would run such a thing, I probably have a different example here. But I have got, do I have Batcat here? I don't. Are you switching my input? Yeah. But I have a very simple example here where I am testing some kind of decode function, and okay, you cannot see it now. Give us a few seconds, and we are back. So we have some test function that it gets some kind of randomized string here, randomized by Hypothesis. And by the way, Hypothesis is also a plugin for PyTest, so it will actually generate a parameterized test inside of PyTest here. And this S will be the input generated by Hypothesis. And it will use this encode function that is imported from somewhere else, and then it will use decode on it, and we expect to get the same string, right? And we can launch it pretty easily with the way as usually you would do with PyTest, and it worked. Something happened. I mean, it tested this function against like 500 different inputs. If I would say here, oh, please generate me like a bit more of those inputs and run it, it will run basically much longer because it needs to generate those inputs and test it. And if there would be some kind of assertion break, we would find it. But apparently, I think this works fine. Okay, and this is Hypothesis. The problem here is that if you would have some kind of like complex if conditions within your program, like the first how it's called, the first HTML tag has to match some kind of tag, like it has to be a body or something. And if Hypothesis doesn't generate this, you will not find some kind of another input in your program that or a code like input that went into this path that expected this tag to be the first one provided. And we can actually mitigate it with this like coverage guided fuzzing. And there is a tool called Atheris. It's written by Ian Padney from Google and other folks from Google. And it's a coverage guided fuzzer for Python and also for C extensions, which is pretty nice actually. It's free and open source. It's on GitHub, on Google Atheris repository. And the way it works is that you write some kind of like fuzzing template that can look like this. So you start with importing Atheris, obviously. then you have to instrument the code you want to fuzz. So whatever code you want to test, it needs to be instrumented. And we will get to this instrumentation in a moment. Then you have to write some kind of function that will give you some generated data, like a byte array or a byte string, I think. And you need to do something with this byte array. So you want to execute whatever code you want to fuzz test here. And then you have to set up the fuzzer and run it. Yeah, so we can actually run it or run some kind of example here. By the way, this didn't finish, but I will kill it. I don't have an example here for. Well, we'll go into running in a moment, but let's maybe start with Atheris code instrumentation and how does it work? Because we want to gather the coverage where we get into our program, like in which paths we get. And if we have an example like this, we can where we have some B library that we are instrumenting, and we call bparse here in the test1 input, providing this data. And in order to see this code instrumentation, like how Atheris work under the hood, we can use the this module from Python. This is the module that can allow you to disassemble your Python code or a function into Python bytecode and see what is there. So if we have this try this as here, this is basically what we had on the slides. And if we execute it here, wait, why doesn't it? Okay, it ran Atheris. It says some information at the start, and then it caught an uncaught Python exception, which was this sysexit that I executed afterwards. So it didn't do much, but it disassembled our function and saved it into this out file here. So we can now inspect this out file, and we can see that here is the code, disassembled code of our bparse function, and I can also show you this function that it doesn't really do much. Like, it has some kind of, if length is less than 2, then return 0, and in some cases it can return 1, 2, or 3. And if we disassemble it, after instrumenting it with Atheris, we can see here that the first things that are happening is we call a function here, and the function that we call is like trace branch function from the Atheris module. So this is the instrumentation that Atheris added. And an idea how it added this instrumentation? Because this is kind of cursed thing. So it took the bytecode of our bparse function, and it looked for some stuff in this bytecode and rewritten this bytecode into a different bytecode. Which is something you probably never should do, but Python allows you to do that. So they did it, and it works. And as you can see, here are like some further things, like we are tracing some comparison here because we are calling a trace CMP function and providing some constant arguments there, which probably tells the Atheris framework where we are in the program. And this code is kind of long, like 90 lines or something after disassembling. I would love to be able to decompile it and show you the Python code that corresponds to this, but it's not possible right now, or at least I didn't find a way. So that's the only way for now, I think, to analyze it, or I haven't found another way. Yeah, and when you run Atheris on normal fuzzing, not like an example where you want to see how it instruments data, then you can see that it starts with some information at start, like what libraries does it instrument, because that's what you wanted to instrument, and you want to be sure that you actually instrument your code. So you can see here what it instrumented. Then there may be some warnings. I don't think they are particularly interesting, but they may be, I don't know. Then there is some further information, like what is the seed of the fuzzer, because the fuzzer has to generate some random data. And so it has some random seed that it uses under the hood. And if you would use the same seed, which you can use providing some kind of command line flag, then it would generate the same data again. And there's some like max length flag that is not provided, so it uses libfuzzer under the hood. That's like a fuzzing framework for C++, and it will basically not generate inputs larger than 4 kilobytes. 4 kilobytes. Yeah, and then you have some kind of fuzzing log, and it can look like this. That's an example, obviously. So on the first column, you have some kind of like ID of an action in the fuzzer, and then you have some other columns. So there are a few columns that are much more important than the others, like this cof here means coverage, and if this number increases, this means that the fuzzer was able to proceed and find new paths into the program. Then you have also like executions per second. You want this number to be as big as possible because if the fuzzer can execute more and more test cases, it's better because it may then find more paths and bad cases. Interestingly, at the beginning it says 0. I think it's because when you start, it maybe just tries and initializes something and doesn't really care about the speed. And at the end, here is some kind of weird things, but that's basically some kind of like method what the fuzzer user used for generating further input, or maybe also doing some other things. And those other things can be, for example, reducing the length of an input that it found that the input like found a new path, because if you are I don't know, fuzzing some kind of XML parser. An XML parser will definitely have some kind of new branch for each XML tag it will find, right? Well, maybe this is not the best example, but basically, you want the length of the input to be as short as possible, because then you don't have to like process so much data, and you don't have to copy so much data around as well. So Atheris under the hood will also try sometimes to like shorter or minimize your inputs that are in the corpus of your fuzzer. And here we can see it that it uses this reduction, and here we can see that this corpus column it goes down in like the number of bytes that are there in the corpus. So it was able to actually reduce and get into the same path. Yeah, and by the way, we can also inspect the code coverage. So I showed you how Atheris is instrumenting things, right? And you can also then tell Python to grab code coverage of the inputs you found. And you should basically do that, because if you don't do that, you don't really know what your fuzzer is doing and whether it gets into some path or not. And if it doesn't get into some path, maybe you want to modify your input data or your mutator, because you can also do that. Yeah, and I've got an example here for this. So let me open it. So we have a fuzzer for Bleach library. It's taken from OSS fuzz, about which I will say a few words later as well. So the way it works, it uses this Atheris fuzzed data provider, because the fuzzer is just generating you some random bytes. And then you probably want to, for example, convert this to Unicode, or maybe generate some integers in a given range. And this fast data provider class that is there in Atheris, it can allow you to do that. And so they are using it here to grab some Unicode string, and then they provide it to this Bleach linkify method. And obviously, they are also instrumenting this Bleach library. So if we run the fuzzer now, and it's as simple as Python 3 your fuzzer, which is not the greatest name here, because that's not the name we have here, and then some corpus directory, which it needs to exist up front. It won't be auto-created. This corpus directory is like, what are the initial inputs for the fuzzer? And if they don't exist because I didn't create them, then the fuzzer will also save the inputs it will generate there. Okay, so we launch it. As you can see, it instruments pretty lots of libraries, because I guess the Bleach makes some internal imports under the hood. And then the fuzzer started and it's running. And how long will it run? An idea? As long as it has to. Well, it will run as long as well until a first crash, basically. And this crash can also be like out of memory if you have a bug in your harness or program. But yeah, so let's maybe allow it to run for a few seconds more, and I will just kill it with Control-C. So it stopped, and there should be some inputs generated in this corpus dir. We can also inspect those inputs. If we try to print them, they may have some garbage data because, well, that's something that the fuzzer generated. We can also like hex dump it and see what's there. And this is some kind of input that the fuzzer generated and found a new path. That's why it was saved. So now we can also grab the coverage for this. And for this, we can use this line, but obviously we have to change your fuzzer into fuzzbleach.py. And what I am doing now is I'm running the coverage module to run this fuzzbleach.py file. And use all those corpus files that are there, and well, run Atheris with this many inputs. And this is needed because, well, for some reason the Atheris doesn't really support one thing, but whatever. So now we restarted, and it will run under the coverage module, so it should save the coverage here. It didn't for some reason. I'm not sure why. Maybe without this pylib flag. If it doesn't save it now, I also have another session which should have something here. Okay, it didn't. Maybe we didn't run it for long enough. And there is also one catch here about which I will speak in a moment. Just let me find the coverage that I had if I didn't delete it. I think I deleted it. Oh, that's a bit bad. But what it would give you, if I have it still open, and I may not have, it would give you some kind of coverage report like this, and then you would be able to go into some given file and see the exact code lines. Obviously, I don't have it now because I removed the files and killed the HTTP server. One catch here is that you can see we have coverage from the fuzzbleach and some other libraries, but we don't really have any coverage for the bleach.py module that is installed in my Python installation. And this is actually the issue, probably why the coverage was not generated. And this is something that should probably be fixed in my script actually, because there's definitely a way to grab this coverage. But yeah. But if we had that, then we would be able to see like into which if conditions the fuzzer went into or didn't went into with the inputs that we had. And probably the main question that we all should ask ourselves is like, what would we like to fuzz in Python? Because I'm speaking about fuzzing and fuzz testing, and you need to be aware like what kind of situations you want to look for. And the first situation can be like, do I handle all exceptions in a given function? And by the way, can anyone tell me what's wrong here in this code? Exception isn't catched. I mean, well, we are catching basically all exceptions, which is a problem usually because you don't want to catch all exceptions. But there is also one particular exception that can be annoying here, that if you hit Control-C when your program is executing under this try except clause, then this except will also catch the Control-C signal and it won't really close your program. I mean, you would probably expect Control-C to close your program or raise a keyboard interrupt, but it will also be handled. So this can be fixed by doing this, by changing to, instead of accept everything, just accept something that inherits from exception. But obviously you can do better. You can, use try except over a given exceptions that you're expecting your code to raise. And that's what you should do. And I have got an example. There's this PyYam library for parsing YAML files or emitting as well. And in their documentation on their website, there is this YAML error that they have documented. And it says, if the YAML parser encounters an error condition, it raises an exception, which is an instance of YAML error or of its subclass. And an application may catch this exception and warn a user. And here's an example. You do YAML load, then you accept YAML error. That's fine. I mean, it's in Python 2 here, but that's their documentation. It also works with Python 3 after you change the Python 2 stuff. They also have this case where you can get some data from the exception where the error position was cool. So if I use YAML load, I should probably always use accept YAML error, right? And I have this fuzzing harness for PyYAML, which is more or less copied from OSS fuzz as well. But yeah, and I'm instrumenting YAML library, and I'm also instrumenting my test1 input function because there may be some interesting paths here as well, and I want to cover them. Then I'm taking the input bytes that will be generated from the fuzzer, and I'm using YAML load. And if there is a YAML error, I'm handling it and returning, because I don't care about this. It's fine. My code will probably handle it as well, because that's documented. Then I am converting whatever I will get from YAML load to list to be able to then emit a new YAML file. So we are like deserializing the string into YAML. Sorry, the YAML string into some kind of dictionary, I think, or another Python object. Then we are converting it to list to be able to emit it into a YAML again. So we are also testing the emit function here. And so let's maybe try to run it. Where are they? But the case that I want to find is so trivial that it might have missed it early on. Oh, okay. You can't see my input. But there is something running on my screen. I mean, fuzzing of PyYAML for the people on the stream. So we are trying to resolve them. Apparently they don't hear us. Or it's likely they don't. Czemu tutaj nie działa? ___. Okay, I need to pass a loader, but it's only a YAML loader warning. So you can see there is this value error. So the documentation says one thing, but apparently the module does a different thing. Yeah, this is this case. But to be honest, this bug was already reported, like in 2021. And someone actually found it with fuzzing. And they found a little bit different case, like dot underscore colon character. But and it's already actually fixed in 6.0 version of PyYAML. I'm using an older version here just to show you this bug. And the fix looked like this, which is not very well, I mean, it's not really shown here nicely, but this is a diff from GitHub. And they changed some kind of regular expression that they use for finding floats, which looks scary to me, honestly, that YAML parsing is being done by regular expressions, but this is how it's done in this library. So going further, what else can you, or you may want to fuzz in Python? Well, maybe some round tripping of serialization and encoding routines. And this is also what we saw in this PyYAML example. We loaded some string and then also tried to emit into YAML whatever we got from loading, right? And here's another example with base 64, because you may want to see if it actually works fine. Another example could be, I don't know, encryption and decryption. Like if you have an encryption library, you really want it to work properly. So you may want to see if RSA encrypt of a given message with a given public key can actually be decrypted, and whether you can actually get, the same message that you provided at first. Another thing you may want to test is comparing two implementations. And why would you do that? Well, maybe you have this case where you use, I don't know, some zip library to zip files, and maybe you are actually like using zip library to zip lots of files or big files, and it's pretty slow. And maybe there is some other implementation which is much faster, and you want to use it instead of the original one. So what do? You replace the library and you run it on production. And then maybe something bad happens because someone finds a bug in this implementation, because maybe this implementation is written in C, and C can have horrible bugs, as you probably heard about, for example, the OpenSSL bug recently, which wasn't that horrible as everyone thought initially. But yeah, and here is an example with actually the zip stuff, and this is from a CTF challenge. And as we can see here, we are getting the data from the fuzzer. We are saving it to a like IO bytes IO, so we are like creating a file in memory, and then we are passing it to zip file and a turbo zip file library that someone created. And in this CTF challenge, it worked like that there was some service that took your zip, it unpacked it with a turbo zip file, it did some validation checks against it, and then it executed something from the zip file, and you had to bypass one of this validation. And it wasn't obvious how would you bypass that. But what I want to show you is actually how you could solve this challenge with Atheris fuzzer. And the fuzzing harness they like, and the organizers written, actually Ian, is here. And here it is. It uses this like load it with zip file and turbo zip file, and then it basically checked all the properties that you have there in the zip file. So check for the comment attribute whether it's exactly the same with this SB compare, which probably compares bytes or also some decoding stuff, as you can see here. And further, it was also checking like things like whether the sizes are the same, whether the file names are the same, and so on and so on. And this is how you can compare two implementations. Another thing you may want to fuzz is to ensure some property is met. And this is the hard thing to do, because you need to know those properties up front. An example of a property can be some kind of whether state transitions in your program that you save an object into the database, then you mutate this in the database, and then it has to I don't know, met some conditions, whether they are correct. Like this could be some kind of API calls. And here's an example on the right side. We have some kind of like an engine with accounts where users can set up accounts, then they can use some operations. They have some balance of their accounts. And so here we can see an example harness where we set up some accounts like a bank account, a user account, and another user account with some balances, and also some kind of bank owner to user one. And then we are taking the bytes that the fuzzer generated, and we deserialize them into some kind of operations that we would kind of randomize the operations that the users are performing, or maybe the bank is performing if it can trigger operations as well. And we call those operations. We handle exceptions because, well, the deserialization may fail and so on. And then we are having those kind of property assertions. So, we started with like 1,110 currency because that's how I set up the accounts. So we probably want to have the same amount in the system, assuming there is no like payment cost for the transfer or something. Then we also want to assert that any balance that is there is bigger than 0 because it should never be smaller, and also that it's maybe smaller than 1,000 because maybe we cannot have some kind of operations that would allow someone to have bigger amount. And also like the owner of the bank is still the same one, because maybe there is some operation that allows one to like switch it, or but maybe it's like disabled, or the user 2 doesn't have permissions or something. And by the way, this example is actually from like blockchain stuff, because like within blockchains you usually have some kind of financial systems where you can either lend money or do some arbitrage on some operations, and you have some kind of accounts with balances and so on. And usually we are also doing something like this with fast testing of blockchain programs. And another thing you may want to fuzz is memory leaks. So any unfreed memory in your program, because you don't want your program to allocate memory infinitely, because then it can crash out of memory, or some memory corruption bugs. And here's actually an example from here's an example that actually Atheris fuzzer found on the Pillow library. The Pillow library is used for parsing images in Python, and the Pillow library is written in C. And this Atheris framework can actually also instrument this C extension code. I don't have an example of that, but it can instrument it. And then it can also, find new paths into the C code, and then find some crashes. And this image on the right side is a report from OSS Fuzz that I will show this report in a moment. But this bug was also already fixed, like in 2021, because it was reported even earlier. And it was some kind of buffer read overrun in some PCX decoding, which is, I guess, an image format. Yeah, and this report looks like this. It says the crash type is some kind of heap buffer overflow. I'll increase this font size. It was found with address sanitizer, which is something that allows you to detect bugs in C or C++ code. And here's also some kind of like additional information, like how to run this with this OSS Fuzz framework. Here's even the stack trace of this heap buffer overflow that was detected. So, it happened in the unpack p2l function that was in this code path, in this file and line and so on. And it was a read of size 1 that was an invalid read out of like some kind of array in C. Yeah, and there's some further discussion there. Let's maybe not get into that. And I said a lot about this OSS Fuzz project. And this OSS Fuzz is actually a continuous, it's a project for continuous fuzzing for open source projects, or fuzzing for free and get notifications about bugs. Because, well, that's also what it is, actually. And the way it works is that you, as a developer, you write some fuzzing harnesses into your project. Then you commit some kind of build configurations into the OSS Fuzz repository that is owned by Google. Then they have some kind of builder that, it takes this build configuration and it builds whatever you tell it to build. and they had some kind of base Docker images for that and scripts around that. Then they have some kind of cloud system, and the build that was built is uploaded there. And then there is cluster fuzzer, which runs this, downloads this this image that was built, and it runs fuzzing over whatever harness you provided on like thousands of machines. And then you, as a project owner, you have also some kind of statistics, whether like how many hours where your code was fast in, and some other statistics as well. And then whenever a bug is found, some kind of situation that your harness was looking for, they will file bugs and verify fixes. And here's also one catch: those bugs that are filed, they're first sent to the owner of the repo, or like anybody that was supposed to be notified. And there is some kind of deadline that usually some of those crashes are not public because they may be, security vulnerabilities, and they will be public, for example, after 90 days. Like there is some kind of flow for this. And when you, as a developer, you are notified, then you fix the bug, and the scheme repeats, and maybe some new bugs are found later on. And there are many projects that are fast with OSS fuzz and Atheris, because like OSS fuzz is not only for Python. You can fuzz C, C++, Go, Rust code. Like there are many projects that are being fuzzed through OSS fuzz. And for Python itself, there are many packages that are fuzzed there, like NumPy, Pandas, Python RSA, Ansible, some rlib3. And also the question is what are the harnesses there, because it doesn't say that the whole library is tested this way. There are probably some functions that are tested, but some functions that are not. But this can always be improved, right? And some people improve it, and you can improve it as well. And I can also show you this OSS fuzz. So this is the GitHub repo for it. They also have this diagram that I showed you. And if you go to projects, you can see here all the projects that are there. And there are many of them. Like, I don't know, ClickHouse, whatever that is, CMake, Dragonfly, Dropbeer. And if we, search for Atheris string in here, we can see some kind of fuzzing harnesses that are there. This is actually for the RSA thing that I showed you before. But yeah, for example, async IO stuff is also fuzz tested here. And they even create some kind of like data abstractions to be able to fuzz it properly. Here is the test one input that, it runs async IO run with fuzz body part reader, and, they are getting some kind of structure here generated from the fuzzer and execute some functions for it. And there are some issues that are there with fuzzers in general, because like it's not so trivial to write a fuzzing harness. You have seen this example with like RSA or with like base64 encoding or like PyYAML. Those were trivial, right? But you may also have programs that are much less trivial. Like if you have an HTTP API, like a Django web application, you can also fuzz it, but it's not trivial to do so. And so there are multiple approaches to it. Like one approach is that you can take the whole HTTP request and fuzz that HTTP request and just push it into whatever handles the HTTP request in Django in your application. Or you can maybe fuzz just the given API endpoint that you have in your application. And one approach may be better than the other depending on your use cases. But I have here some examples for like issues with fuzzers. So one big issue is like non-fuzzable code by default. And here's some function that it opens some USB device and reads some bytes out of it, like size number of bytes, and then it reads this number of bytes. How would you actually fuzz it? Since it opens a device. So this may not be that trivial, but in order to fuzz it, you actually have to mock it as if you would do with normal testing. So you would make open call to return some mocked object, and then you would use the fuzzer data provider that you already seen in some examples to change this USB read function so that it actually generates some kind of data from the fuzzer. And that's how you would actually be able to fuzz this kind of example. Yeah, another case can be when you have something like this, that there is some integrity or signature check in your application. Like if your application is checking that the signature of data that is provided matches the expected signature, then there is no way that the fuzzer will actually generate data with this with this exact expected signature, because the signature can be like 16 or 32 bytes, and it's hard to generate this amount of bytes that will match the expected one. So for this, you would probably just comment it out. I mean, comment it out this code or mock it somehow as well. Or maybe handle this explicitly, by which I mean that you would actually extend the data that was generated by your fuzzer with the hash or signature that is expected there. Well, this may not be the best example. It should be maybe a signature, not a hash here with an expected hash, because an expected hash would need unexpected data as well. Yeah, another issue could be some kind of non-deterministic execution, because the fuzzer is looking for some code paths, but whether you enter a given if condition depends on a random number that is generated, then you don't want to generate random numbers, like totally random numbers, every time you re-execute the harness, the fuzzer. And so if you have an example like this random round int here, then you can solve it with some, just set the seed to some constant value. And this is not ideal, because this means that you will probably always generate the same values. But if your fuzzer is doing this fuzzing in a loop, then it will actually generate other data in the future. So this may be fine. Another thing is some kind of complex or hard to fuzz code. And if you're parsing an XML or super complex format, an XML may, some kind of specific XML parser for some, I don't know, HTML or something may expect some specific tags to be there. And how does the fuzzer find it? I mean, it will have to generate it somehow automatically. One thing to do it is to create some kind of custom mutator. And here is an example from Atheris documentation, where they actually are fuzzing zlib. This is not the function that fuzzes, but this is a custom mutator. So it takes some data generated by the fuzzer, it tries to decompress it, and if it gets an error, it will switch it to something else, and then it will mutate it, and then it will return a compressed data, so that the actual fuzzing function can decompress it later, I guess. Yeah, but this is an example, right? You could also have some kind of grammar or dictionary fuzzing here. So you could take whatever HTML tags you have in your application and put it as a dictionary for the fuzzer, because there is an option to do so. And it can use that to generate data. Another case is hard to hit branches, because the fuzzer will try to get into an if condition, and it finds an input that gets to an if condition. It will save it for further mutating this input, because that's an interesting input that found a new path in the program. But what if you have something like regular expressions? They may have thousands of branches there, and there may be even infinite number of inputs that are allowed for a given regular expression, right? Actually, Atheris has some kind of hooks for regular expressions that it can instrument them. So there is one way. Another way is generating some valid values for your regular expressions. And another hard to hit branches case is, what if you have an if condition like this in your code, that your data must start with some predefined prefix. Well, you can specify this prefix yourself, right? But if you're fuzzing some complex code, then you probably cannot do this. Yeah, so realistically, it may not be so easy to do so. But there are also two other ways. And one is you could make it so that the fuzzer itself, like Atheris, when it instruments some libraries, it would take all literals used by those libraries, and it would use those values for further mutations of inputs. And some fuzzers are actually doing this. Another approach is you could actually simplify or split this condition. So, because we have some kind of precondition here that you need like 10 or more bytes to be to match a specific prefix, but you could switch it to something like this, where you would expect the length of the data to be greater or equal to the length of the prefix, and then you would actually have branches for each of the letters separately. What does it give to the fuzzer? I have shown you this instrumentation made by Atheris, right? So it inserted some kind of additional bytecode, which was checking whether we went into a given path and like saving this information somewhere. And if we would have this if condition on the upper, then maybe Atheris would just have a one branch here and only save information whether we actually match the whole prefix. But if you have this second example, then it would insert this instrumentation after each of the condition, and it will be much easier for the fuzzer to get there. The question is Atheris doing any of those two? I have no idea. I haven't checked. I hope it does, and if it doesn't, I hope they add it. I guess this may not be that trivial to do, and they probably don't, but it would be nice if it did. Yeah, and another case is this native code stuff. And what I will say now is not necessarily only related to native code. Whatever you want to fuzz, it needs to be instrumented. I already said that today. So what if we create a harness like this, where we want to test this base 64 encode and decode like logic? And I can actually show you this in practice. Base 64 decoding should have like lots of if conditions, because there will be a for loop, and for loop is actually generating lots of branches usually. I don't have an example here, but I probably have it here. Yeah, so this is the exact code that we had on the slide, where we are doing this flow of base 64 encode and decode. And let's run this. So if we run it, we are seeing that the fuzzer is working. It has like 300,000 executions per second, but the coverage is staying with a value of 10. Why is that? Because we are not really instrumenting the base 64 library. And why we are not instrumenting it? If I said that I actually want to instrument those imports, and it said that it is actually instrumenting base 64, even some struct library that one of those libraries that I instrument is importing. So what is happening here? Well, if we go into IPython and we look over the function that we are fuzzing, the base 64 B64 encode, and we want to see its source code with double question mark, we can see that it basically will start with a call to bin ASCII B2A base 64. So let's see what is that. And let's see its source code. And we cannot. Why? Because it's written in C. And since it's written in C, and CPython that I use here was already compiled, and it was not compiled with libfuzzer instrumentation, then I'm not getting this information about the coverage from this function. And my fuzzer is just trying to randomize some inputs, but it will never find an actual path. So it's like a dumb fuzzer here. Yeah, I will kill it now. So this can be tough. I think there was one more issue that I wanted to mention here, but I don't remember it right now. But that's pretty much it from me. And I hope you learned something today. And if there are any questions, I can answer them. Thank you.
If you have any questions, please tell them to the microphone so we can have them on stream. So,
in example that you showed, you provided a body that contained HTML code. Is it possible to generate like valid examples of HTML code, or fuzzer will generate only some random values?
Yeah, so that's a really good question. I guess it probably is possible to generate random HTML. One example to do this would be using fuzzing dictionaries, which is not the best method, but it would somehow work. And if you go probably to a repository from another fuzzer which is called AFL++, they have this dictionaries directory with, whoa, what did I do? I switched. How do I get back? Okay, I'm back. And they have like dictionaries for different formats, and probably one format here will be HTML tags. And you know, they are defining some kind of tags here. And you know, this is not the ideal solution, but this is one possible solution. And this dictionary will most likely work with libfuzzer as well, which Atheris uses under the hood. I haven't checked whether Atheris actually lets you specify this. Atheris GitHub. Well, actually, I may try to just pass in a dict with some dev null. Yeah, it probably supports it because it says parse dictionary file. File doesn't exist. I guess we have a question from the internet.
Not question, the response from the creator of Atheris. Atheris does that with conversions. If you write A equals foo, Atheris will detect the foo and add it to the dictionary. However, probably wouldn't work with starts with and Swift. I should do that. So probably a feature request was already created.
Yeah, so if I understand correctly, if we do this, then ABC will be added to the input or maybe the mutator. But with A starts with, not necessarily. The problem, by the way, the problem with getting all those literals and putting them into the mutator is that you also have lots of literals that are related to logging, which are usually useless. Like if you have, you know, log info and some string formatting, blah, 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 then this is something that you don't really want to add to your mutator. And in theory, Atheris could probably detect this and like skip those. Or maybe it could generate you a file and you could look up what is interesting and what is not and maybe filter it somehow. I don't know. There is lots of like research and improvements that can be done in this space, especially that this is kind of something new. Any other questions or comments?
I have a question. On the last slide, you showed the C extension thing with that you cannot fuzz it because the Python wasn't. Yeah, this one. So what would you need to do to actually fuzz that code?
That's a good question. Most likely, you would have to compile your CPython with fsanitize, address, and fuzzer flags. Most likely, it's only this. I'm not like quite sure how it works with CPython, but we can probably look up in the Google Atheris docs. I hope there is something about it. There should be. Whoa, sorry. If you plan to fuzz native extensions, you may need to build from source. So you have to build your extension or CPython from source. I hope it supports CPython. I'm pretty sure it does. And you need to ensure the libfuzzer that was used also in Atheris matches your Clang version. This may be problematic, but if you would use a Docker image from OSS Fuzz, most likely it will work. I bet at least. And they even have example how to install it against a new LLVM version, because libfuzzer comes from LLVM. And you can also like tell it to instrument everything, which may sometimes be better than like marking what do you want to instrument. Anything else that I missed? Apart from custom mutators, there is also some kind of libprotobuf mutator as well. So this can also be used if your program is using protobuf. Anything else? Yeah, there are some docs, and this like fuzzer data provider has different functions, like create me a list of integers, maybe. Yeah. Any other comments or questions?
Yes, is there a question? Okay. Do we have any other questions? Okay, so I guess that's all. So another round of applause for Dominik, and we'll take a.
Okay, we have one more. One more comment.
Sorry, one more response from creator of Atheris. Yes, it supports CPython. Instrumenting all of CPython is really slow. You probably want to extract the specific module you want to fuzz and instrument only that.
Yeah, that makes sense. And if you are compiling some libraries, you may actually want to pass a different flag here, which is fuzzer no link, so that it doesn't link libfuzzer into your library, because what libfuzzer is doing under the hood, it is giving into your code its own main function, and this main function from libfuzzer is called, and it basically will execute whatever harness you want to use in a loop later on. Yeah, but this is a bit not exactly the same in Atheris. I mean, with Atheris you write the Python script. Yeah, thank you.
Okay, so thank you, Dominik. And we're going to take like a 5 or 10 minute break, and after the break we're going to have the lightning talks. So enjoy the pizza if there's anything left, and the beers, and see you in 5 minutes.
Okay, so I am doing the first lightning talk, and this will be partially a continuation of what didn't work on my presentation. What didn't work was visualizing the Python code coverage, and I have used this, code line that was suggested here with like Python coverage run, your fuzzer, corpus directory, and this Atheris runs flag. And the author contacted me that I should have tried without this 1+ here. So we want to run one less test case for the Atheris runs. And if we do that, which I have here, there is no +1 here. And, I am running this thing and then converting the coverage to HTML and serving a web server. And I can show you that there is no like .coverage file that will be generated or HTML dir. So if I run it now, it will run it against the inputs that are there in the corpus saved by the fuzzer. It did it in 1 second, and now it wrote the HTML report and served it on the website. And if you go there now, oh, it's interesting. Now it actually works with even more libraries. Okay. But there is still no bleach, is it there? No. But you can go there and you can see that on the green here on the left, yeah, you can see it actually, are the lines that, were discovered by the fuzzer. So in this file, it's all the lines, obviously. But if you go to some other file, like, I don't know, some XML stuff, there are some functions that, were defined when importing this module, I guess, but this function was never executed. Well, because maybe we didn't even went into this error handler here. And so on and so on. This is probably not a very interesting file. But yeah, this is an example coverage report. Another thing that I wanted to say is that I said there are some issues with fuzzers. And there is also one big issue that I have missed, which is global state. Which means that if you have this like function called, test1 input that takes the data, whatever is executed here probably needs to start with like clean state of your program. So if you have some kind of global state like a database, then probably you want the database to be reverted after this call to whatever you are doing here. And one more thing that I wanted to show you, which is not necessarily related to the talk, is that I have been speaking about this hypothesis framework, and apparently there is a thing called hypofuzz, which is some kind of fuzzing framework or fuzzing backend for test suits written with hypothesis. I've never tried it. I have looked a bit into this into their documentation, and they have some kind of dashboard here. Oh, I don't know what is here actually, but basically you are having some fuzzing with it as well. And here are some statistics from the fuzzer, I guess, and maybe some inputs that it generated. I don't know. Yeah, so that's it from me. Thank you.
Do you have any other lightning talks? Like, I'm looking at the candidates for lightning talks. Do you want to do the lightning talks now or later? Yeah, I can. Okay, cool.
Hello. No, I don't need anything. Hello, I'm Bartek, and I'm an alcoholic. No, wrong meaning. I'm Bartek or Poker. I mostly come from the speedrunning and speedrunning events background, which kind of crosses over to the IT world. I'm not really someone from an IT background. I don't have a technical degree, and Artur kind of convinced me to speak a bit about how I came here. I have only a couple of months of actual experience with Python, and I kind of started to get more control out of my own computer. And it's kind of different because I never actually intended to work with it professionally. It's only kind of a passion of mine. And I'm in this state where I don't know if you know the feeling, but when you start learning a new language, like an actual human language that people speak, you get this feeling that give me a dictionary and I will tell you anything, because you kind of get the grasp of it and you feel like you can do anything. That's how I kind of feel about Python right now, even though I'm a dummy in terms of IT. And I just wanted to tell you that you seem like a pretty welcoming community, and I will be coming back. So thank you.
Hello everyone, my name is Victor, and today I wanted to talk more about real communication rather than the programming languages. Continuing the topic that Bartek mentioned, the real languages, the communication between the people. Usually these days, the internationally recognized language for communication is English, but there are obviously some cons with the language, especially in the Slavic countries, due to the fact that it's pretty different from the native language of many Eastern and Central European countries, which makes, obviously, it hard to learn for the population. So the solution for this is the Inter-Slavic language, or Междуславянский язык, which is a modern project which kind of creates a hybrid language between all of the other Slavic languages. It's done this way that most of the people from all the Slavic countries will be able to understand at about 90-95% of the spoken language without any learning. This is done by a team of people from all the Slavic nations that discuss each word if it's recognizable in their language or a specific dialect. And the language itself uses, obviously, the Latin alphabet as the main one due to it's the most understandable within the Slavs. Also, Cyrillic and Glagolic alphabets are used, but as you might assume, Glagolic is pretty rare these days. And about the grammar, which is an important point. The grammar is regular Slavic grammar, which means like pretty hard grammar, but without that grammar that those Slavic languages offer, it wouldn't really be understandable, because it's just those suffixes and the endings that add more life to the actual talking and the language itself. So the grammar is still there with the conjugation and stuff, but there are no irregularities. You just learn the rules and you use them, and it should be perfectly understandable. And there's already a big community of the language, as long as it is a fast developing project. There are many programmers working for this project, and that's why stuff like the dictionary, online dictionary app was already created. That's already available for Android, and soon going to be available for iOS. There's currently there's in development the inter-Slavic version of Telegram, and there are also many other projects that currently are being developed as learning apps, similar to Duolingo or other stuff, to just make some people try to master the language if they want to. Obviously, the point is not to get rid of the cultures of each Slavic country, because in each Slavic country, their native language will still be a primary language of communication. It is just when the person from Serbia will meet a person from Poland or something, it'll be much easier to understand them if they would speak in a language that will be between both of them. So I hope this project is gonna grow. If anybody is interested, it's just a very cool topic, in my opinion, to talk about these days, because it'll just make life for Slavic people quite a bit easier in the modern society. Thank you for attention.
Do we have any other lightning talks? Okay, if we don't have any other lightning talks, I will do a lightning talk as well. I do have slides, but it is non-technical as well. As soon as I can get it on the screen. Okay, sorry for the interruption. We're back with a different computer, and the slides are here, but the tabs that I had open in the browser I won't be able to show you. But yeah, so Dominik actually asked me today to do the lightning talk, and I usually encourage people to do lightning talks about something that they've done last month, and I haven't done much programming last month, so it's going to be non-technical talk as well. But what I've been doing is figuring out where the next EuroPython is supposed to go. So I'm going to talk today about the process of how EuroPython selects the next location a bit, and where are we with that process. So this is like a TLDR of that process. Basically, you need to get a list of all possible locations, and that usually comes from the community or the research from previous years, because the EuroPython travels around every year around Europe. We usually have a list of possible venues and cities that we can go to. By the way, who knows what a EuroPython is? Okay, not everyone. That's a conference. That's a conference that happens every year. It's the longest running community organized conference for Python in the world. It's been 21 years, I think. This one was 21st. And except for the 2 years when it happened online, in 2020 and 2021, it's been happening somewhere in Europe. And this year it happened in Dublin. In 2019, it was in Basel. Prior to that, it was Edinburgh, and so on and so forth. It travels. And right now, we need to figure out where the next conference, so the 22nd conference, but for the year 2023 will happen. And so yeah, that process includes looking at all the possible locations in Europe and then narrowing down the list of possible locations by community input, by looking through lots of spreadsheets, sending lots of emails. It's basically part of it is a very commercial process because it's a big event, so it requires a lot of paperwork to organize and comparing bids from different venues and so forth. And basically, we run that process until we have a location. So this is a screenshot of the timeline of how it's going to work out this year. There's a missing slide here because I'm supposed to have the browser, but I don't. So in September, I think September 10th, we launched a community call for venues where the community could propose the locations for next year Python. We took that input and then send the formal request for proposals to all the venues in Europe that were suggested. And that happened on the October, and now we're sort of starting we got the answers and we started narrowing down the process. And we were basically here, so we finished the first round, and now we're going to send the second round to the candidates that were shortlisted from the round number 1. And this is the screenshot from the actual spreadsheet. The green ones are the ones that were selected for round 2. The red ones are the ones that didn't make it. You can see the spreadsheet goes to the AR column. And I can tell you that there's one thing that was less blurry on this slide, and that's Krakow. So Krakow so far made it to the round 2. As you can see, there are 5 other venues that are being considered at the moment. And what I would like to hear from you is some feedback about that. What do you think about this idea? Would you like to help organize EuroPython in Krakow? That doesn't mean that it's going to land in Krakow yet, but there's a chance. So yeah, and I think that's it. And yeah, if you want to know more about EuroPython, you can talk to me later. If you want to know more about EuroPython in Krakow, you also talk to me later. Okay, bye. Okay, so if we don't have any other lightning talk ideas, Maciej, do you have a lightning talk idea? Would you like to present your lightning talk? Okay, would you like to join us here and present your lightning talk? Do you need the projector thing? Okay.
Okay. So first of all, yes, classic. Okay. So hello everyone. I have a very quick lightning talk. Have any one of you? How many of you have heard about local similarity hashing? Whatever. Yeah, so that's great. Not all of you. So local similarity hashing essentially answers the question, what if hashing was better? In that sense that not only we are having a hash as a result of a function, but also we can compare two hashes. So we can have a distance metric between two hashes. And that is very useful. For example, I think I might be slightly mistaken, but I think Google used it for comparing images, right? Because you can hash pretty much the whole image and then compare the distance. What the distance means is that you can find similarities. Similarities meaning you can find similar images. So there is one very nice, very small library in Python. Okay, sorry. I'm not sure if I will be able. Oh, yes, it works. Better? Yeah. There is one small library in Python that does that. It's l/py free. l/py doesn't work. It was for Python too. This is very old library. It appears. So this is doing exactly that. This is local similarity hashing. I think local similarity hashing can be done in multiple ways. Am I correct? Right? Okay, never mind. This one has only one way implemented. So what we do here is we have an array, a list, a simple list here that we are putting into index. And we are having other lists also put into index. This is kind of like putting things into a database. So then when we have this database created, at least this is how this is implemented here, we can make a query. And with this query, we can get nothing, apparently. Let's go again. The implementation actually in this library is lacking, but this is one of the very few that is available. So we inputted this array, 1, 2, 3, 4, 5, 6, 7, 7. And actually, we indexed this array, 2, 3, 4, 5, 6, 7, 8, 9, right? Like on a first glance to a machine, there is a lot of difference, right? Especially when it comes to positioning here. But it finds that this is the most similar out of those 4 arrays. This is the one that is the most similar. So we can try here. Let's add a print here as well. And then, okay. So let's try to get it to some other result. If it doesn't find a good similarity, it will output an empty list. Let's go with 12 here. So 99. Oh, let's make it, I don't know, 96. Will that help us? No. And 1. Let's maybe get it here. The problem with this implementation of this algorithm is that it is non-deterministic. There is a random array being computed. And actually those parameters that I'm putting here sort of are conditioning how this algorithm will behave. And there are, of course, other implementations, and this might be useful for you someday if you would like. This is actually quite fast operation as well. Night shift. It's orange, your screen. Oh, yeah. It's like a former president of the USA. Okay. Okay. So that's it when it comes to this. To those people who are new to Python, I just wanted to show one thing. Where was it? Oh, yes. A classical strip from the comic. So learning Python is like learning how to fly, and this is a comic that actually ended up in Python distributions, right? There is a library that you can import, anti-gravity, I think it is. Yeah. Yeah. Right? And yeah, and it opens this one. Okay. And I think that's it from my side. Thank you.
Okay, do we have any other lightning talks then? Okay, I think we ran out of lightning talks. So we have 2 more items on our agenda today. One is to announce the next meetup, and that's going to happen on the 24th of November at Atheris. You can go to the website and see all the details. And another thing is we need to give out 2 PyCharm or 2 JetBrains licenses, and I'm going to give a microphone back to Dominik, so he will figure something out.
Yeah, so we have this competition where I'm going to ask 2 questions. Well, the first question for the first slide and the second question for the second slide. And whoever asks first the correct answer will get the license.
Yes, I would like to point out one more thing that only applies to people in the room. That's not available on stream, unfortunately.
Yeah, we can.
Okay, so so I'm going to use this opportunity to say goodbye to everyone on stream because the competition is only for people present on site. Okay, thank you for watching and see you next one.
Yeah.